Let me show you how to do the calculations now that you have the data there. Okay, so these are the two radiuses. So this was the original radius, that's R1. This is the second radius. I pulled it into that distance, right? And then these are the times. Now let me just show you where these come from. So this is the time when it was on my left side for the first time, and then this is when it was on my left side the second time. Okay, these numbers come from here, right? So there's my 3.637, 2.635 is there, right? Okay, and then here is the 4.403 and 4.972, right? Okay, and then these are those distances. Remember, we measured those using the little this tool right there. Okay, so that's where those come from. So let's do the calculations. The basic calculation is this. Okay, we need to, from these two numbers, we're going to subtract these guys, right, and find the period. So let's do that. The period for this guy is equal to T1. We'll call this, right, is equal to 3.637 minus 2.635. which is, of course, 1.002. Now that is plus or minus, in my camera, right? I'm going to be healthy about this. I'm going to say that I might have been off by a couple frames. Do you think? Right? So that is plus or minus 2/30ths. Because my film is taking 30 frames a second. Okay, I could have been off by a couple frames. I don't think I was. Okay. But I think I could have been, right? Maybe I'll make that 1. I'll say it's 1/30th, okay? Because I really don't think I was off by more than 1 frame. Okay, and a 30th, 1 divided by 30 is 0.033. So plus or minus 0.033. That's a 30th of a second, okay? And then my T2, so this is just 1.002 plus or minus 0.033, okay? And then T2, let's do this. This is going to be this minus this. So 4.972 minus 4.403. This is 0.569, 0.569. And that is plus or minus 0.033 seconds, right? It's also a frame of video, right? Okay. Now, the formula to figure out the velocity is that the velocity is just circumference divided by period. Okay, so for R1, okay, my velocity equals 2 times pi times 1.677 divided by 1.002. Okay. Okay, so let's do this. 2 times pi times 1.677 divided by 1.002. This is 10.51. Is that right? Meters per second. Did I do that right? 2 pi r over t. 1.677. All right, now let's do for the other one, right? Same thing. We're just going to go v is 2 pi times 1.063 divided by 0.569. 2 times pi times 1.063 divided by 0.569. And I get 11.74. So it is actually, looks like it's going faster, right? But we really don't know here because these are pretty close, you know? That's like only 1.2 away, 1.23 away, right? So the question is, how big is our uncertainty, right? So what you want to do, you know how we went in here and we did this, we did these measurements? Do those measurements 3 or 4 times so that we get trial to trial uncertainty. We just sort of like guess what that is, right? And what you want to do is you want to get a bunch of different R's. Okay, get like 5 different R's. Measure that, you know, just like whoop, and erase. Then close that thing. Close that thing. You measure it, close it, measure it, close it. Right? Okay. And then hopefully we can come up with an uncertainty of the R. So let's imagine that this R is plus or minus. By the way, it's going to be plus or minus high minus low divided by 2. If you did 5 trials, high minus low divided by 2. Okay, so let's imagine that this is plus or minus. And these are meters, right? So let's say it's plus or minus 5 centimeters. Okay, so it's plus or minus 0.05. How do we find the uncertainty of this? Well, the uncertainty of the velocity is to the velocity is equal to the uncertainty of time over time, so 0.033 over my time, which was 1 point, plus we'll say 0.05 divided by 1.677. So maybe that's my uncertainty. Right? So now take that 10.51 number, multiply by this whole thing in parentheses, right? So times parentheses 0.033 divided by 1.002 plus 0.05 divided by 1.677, right, parentheses. And I get that this is plus or minus the delta V for this is 0.66 roughly. Well, hey, that's getting kind of tenuous, right? You know, that 0.66 plus is going to be 11.17, right? That's getting close to this. So let's look at the uncertainty of this guy. This guy is going to be uncertainty of velocity over 11.74 is equal to 0.033 over point. And this is why, by the way, if you use a high-speed camera, like a 60 frame per second camera, you'll be less uncertain about that, right? Okay, and then that is over 0.569, okay? And then this is plus, I'm going to say 0.05 divided by 1.063. Okay, so again, you're going to take that 11.74 number and you're going to multiply by these fractions. Okay, so 0.033. And by the way, if you are using a 60 frame per second camera, you'll do 1 over 60 for that. So this will be smaller. I've got an iPhone 5, I'm sorry. Okay, divided by 0.569 plus 0.05 divided by 1.063. So this will be a bigger number. 1.2 plus or minus delta V is plus or minus 1.2. Now, look at my values here, right? This is what I'm getting. I really haven't proven the constant velocity model incorrect because I've got 10.5 plus or minus 0.7, right? Here I've got 11.7 plus or minus 1.2. Well, guess what? If we take 11.7 and subtract 1.2, don't we have 10.5? Right? And so these things actually overlap. I have not disproven the constant velocity model. I've not disproven that, right? And that's really all we can do is disprove something, right? Okay, so yeah, happy hunting. The basic formula is just V is 2 pi r over the period, right? The period will be the difference in those times. Yeah, all right, good enough.